Hello everyone. Today let's see some applications of graph coloring scheduling problem. Graph coloring is a mathematical method used to solve conflicts and scheduling problems. Suppose multiple different events occur at any given time, but some events have conflicts. The minimum number of time required so that all the events can occur. Such type of problems can be modeled using graph coloring. So here vertex represents job to be scheduled, color represents available time slots, chromatic number gives the minimum number of time slots required to complete all the jobs. There are two types of coloring. One is vertex coloring, the other one is edge coloring. Vertex coloring applied when the objects are assigned to the time slots. The vertex represents the item to be assigned or scheduled. In edge coloring, here the edge represents the activities to be scheduled. Here are some applications of vertex coloring: exam timetabling, map coloring, frequency assignment, traffic signal optimization, and so on. For edge coloring, tournament scheduling, employee shift scheduling, flight scheduling, network communication scheduling, and so on. Let us discuss some questions. First question: there are 8 people, say A, B, C, D, E, F, G, H. There are 7 teams. Team 1 consists of member A, B, and C. T2 member C, D, E. T3 D, F. T4 A, G. T5 E, H. T6 B, E, G. T7 C, F, H. So by using graph theory, we need to model the graph where vertex to be considered as the team and the edge will be when the two teams have the same, common member. Apply vertex coloring to determine the minimum number of time slots required to conduct all team meetings without any employee attending 2 meetings simultaneously. So let us draw the graph based on the given data, considering the vertex as the teams T1 to T7 and the edges going to be when the teams have common element. So T1, let us compare with the other teams. T1 can be compared with the T7, T6. So T7 and T6 have common element C and B. So there will be an edge between T1 to T7 and T1 to T6. And T5 does not have any common element. T4 and T2 has common elements C and A. There exists an edge. Similarly, we'll plot for other vertices T2, T3, T4, T5, T6 and T7. So now T2 is connected with T1, T7, T6, T5 and T3. T3 is connected with T2 and T7. T4 is connected with T1, T6. T5 is connected with T7. T6 is connected with T1, T2, T4. T7 is connected with the T1, T2, T3 and T5. So now we are going to give the color for the vertices, and the condition is no two adjacent vertices should have same color. So here T1, T3 and T5 are non-adjacent vertices. Let me consider red color for this. T2 and T4 are non-adjacent vertices, so black. T7 and T6 are non-adjacent vertices, green. So the minimum number of colors required to color the graph is 3. That is, the minimum 3 meeting time slots is required to conduct all 17 meetings without any scheduling conflicts. Here's the second question. The following graph shows the traffic line at the intersection of two streets. and the traffic light is located at this intersection. So during a certain phase of the traffic light, vehicles in the lane for which the light is green may proceed safely through the intersection. Determine the minimum number of phases needed for the traffic light so that all the vehicles may proceed through the intersection. So this is going to be done by graph coloring. That is, if two traffic movement intersects or interfere with each other, the corresponding vertex are connected by an edge. To ensure safe traffic flow, the adjacent vertices must receive different colors. So we are going to plot a graph according to the condition. Each color represents separate traffic signal phase, allowing non-conflicting traffic movement to proceed simultaneously. So now let us consider the graph with the vertices considering the traffic lanes L1 to L8 from the given figure. So there are 8 vertices L1, L2, L3, L4, L5, L6, L7 and L8. So based on the intersection, let us introduce the edges between these vertices. So L1 is intersecting with L3, L5, L7 and L8. Then L2 is intersecting with L3, L4, L5, L6, L8. L3 is intersecting with L1, L2, L8, L6. L4 is intersecting with L8, L7, L6, L5, L2. L5 is intersecting with L1, L2, L8 and L7. L6 is with the L2, L3, L4, L7. And L7 is with L1, L4, L5, L6. L8 is intersecting with L5, L4, L3, L2 and L1. So the degree of the vertices will be like for L1 it is 4, L2 is 5, L3 is 4, L4 is 5, L5 is 5, L6 is 4, L7 is 4, L8 is 5. So now we have to color the vertices based on the condition that no two adjacent vertices will get same color. So L1 and L2 are non-adjacent vertices. We are coloring it with orange. L3 and L4 are non-adjacent with a different color. L8 and L7 are non-adjacent, plotting with the green color. L6 and L5 are non-adjacent, plotting with blue color. So there are minimum 4 colors required for the vertex coloring for this graph. So the minimum number of phases required for traffic light so that the vehicle can proceed through the same lane is 4. So from this graph coloring, we can conclude that L1 and L2 can proceed at same time. Similarly, L3 and L4 can proceed at same time. L5 and L6 can proceed simultaneously. L7 and L8 can proceed simultaneously. So this is how we are modeling the given data through vertex coloring. The next example. An electric power network consists of 6 substations A, B, C, D, E, F. The power lines connecting the substations are given as A, B, AC, BC, BD, CE, DE, EF and DF. Each power line requires periodic inspection. For safety reasons, two power lines sharing a common substation cannot be inspected simultaneously. Represent the substations as vertices and the power lines as edges. Construct the graph and determine the minimum number of colors required for edge coloring. So from the given question, let us consider the vertices as substations and the edges as power lines. So we can construct a graph of power network considering these substations as vertices A, B, C, D, E and F, and from the given data we'll construct the edges between the vertices A, B, A, C, B, C, B, D, C, E, D, E, E, F and D, F. Now let us color the edges. So here A, B, C, E, D, F are non-adjacent. So we are coloring it with red. And AC, BD, EF are non-adjacent. Let us color with green. And DE is colored with black. So therefore, the chromatic number is 3. Hence, all power lines can be inspected in 3 time slots without any conflict, ensuring that no two power lines connected to same substations are inspected simultaneously. Just do one more question. Example number 4. 7 volleyball teams from cities C1 to C7 have been invited to participate in tournaments where each team is scheduled to play a certain number of other teams. No team is to play more than one game each day. Using graph theory, set up a schedule of games over the smallest number of days. So finding the edge coloring number and minimum number of days we are going to construct based on the given data. So here are the data. Here C1, C2, C3, C4, C5, C6 and C7. So based on this, we have constructed the graph. C1 is connected with the C2, C3, C6 and C7. C2 is connected with C1, C3 and C7. C3 is connected with C1, C2, C4, C5. C4 is connected with C3, C5, C6, C7. C5 is connected with C3, C4 and C6. C6 is connected with C1, C5, C4, C7. C7 connected with C1, C2, C4, C6. So based on this given data, we have constructed a graph. Now, the coloring, so that based on the same condition, so the non-adjacent edges we are going to choose to give the same color. There are totally 13 edges and the maximum degree is 4. Now C1, C2, the edges C1, C2, C3, C4 are non-adjacent. C1, C6, C4, C7, C3, C5, green. C2, C7, C4, C6. So this is how we are giving different colors which satisfies no two adjacent edges has same color. So here there are five colors: red, orange, green, blue, and black. 5 colors for the these are all the minimum number of colors required. The edge chromatic number is 5. Minimum days required is 5. The conclusion will be like all the 13 matches can be successfully scheduled over 5 days, with every team playing at most one match per day. So from the given data, we are concluding with the statement where 5 days required for every team to play at most one day. The last one, fifth question. There are 7 railway stations. S1 to S7 are connected by direct train service. Each train service operates between 2 stations, assuming that each station has only one platform, so that it handle only one train during a given time slot. Consequently, 2 train services shares common station and cannot be scheduled simultaneously. The train services are as follows. The train services are given here: S1, S2, S3, S4, S5 to S7. Using graph theory, the train schedule with the minimum number of time slots we are going to do. So let us consider the vertices with the stations S1 to S7. Now let us plot the edges between the vertices based on the given data. Now let us do the coloring for the edges. There are 7 vertices. So let us color non-adjacent edges. So the minimum color required for edge coloring here is 5. So the railway network is represented by a graph in which the stations are vertices and the train service are edges. Since a station can handle only one train during a given time slot, adjacent edge must receive different color. So the minimum time slots required to schedule all train service is 5. Also, the coloring shown in the previous questions, these are all valid, but it can be in different assignment also. Different assignment is also possible. Thank you.